going to be working on 7D today. So 7D is focusing on determining what transformations have occurred to form an image from an original graph. So to start off, we are just going to look at understanding what are combinations. So it's literally just we are working backwards to find out what changes were made to the graph. So that's really all we're doing. Now, one of the things I've gone through in the previous videos is Dr. T. So Dr. T is what we are need to focus on, and that is the order that we're doing everything. So D stands for dilation, R is for reflection, and T is for transformations. Now, this is just a quick summary of the transformations that we've gone over. So if we're doing any translation of vertical and horizontal, all we are doing is we are adding a, a value or taking away a value to our y. The next thing we need to think about is our dilation. So we know a dilation from the x-axis means if I have a graph, so say I have a graph here, I am pushing away from the x-axis, which means my y value. So if this y value here is 1, it's then going to be pushed up by that same amount. So that is my A, my scale factor. Likewise, dilation from the y-axis is pushing out from the y-axis. So the same thing applies, but this time because it's next to the x, it's going to be a scale factor of 1 over b. Then we've got a reflection in the x-axis, where we've got a negative on the outside, and reflection in the y-axis, where the x value is got a negative. So let's look at this. We've got a original graph of y equals x squared, and we need to think about getting the image. So here, the first thing I'm wanting to think about is Dr. T. So D is dilation. So straight away here, I can see that I'm going to have a 3 out the front here. So I could say that I've got a dilation of from the x-axis. We can think about it as y equals a f of x, and so I've just got that 3 there. So I can just put that 3 out the front here. So that's just saying I've got a dilation factor. I can write that. No, dilation factor of 3 from the x-axis. Then I'm going to look at my translation. So my translation is I've got two parts. I've got the +1 here, and that is referring to my horizontal shift. And we know how do we make that 0? X will be -1, so it's a shift in the negative direction by 1 unit. And then we've got a vertical shift right here, or with the, oops, sorry, my pen's being silly, of 5. So we're going down by 5. Okay, let's look at this next one. So this one here, it makes it a bit harder because we've got 2x minus 4. We need to make sure we have factorized this so we can see what is actually going on with that horizontal shift as well. So this is where the first thing that I would be doing is factorizing. So I would factor out the 2, and even if it's not a lovely factor, still factorize it. Just leave it as a fraction on the inside. So this gives us y equals square root 2, then x minus 2. So the first thing I need to think about is when it's got 2 in front of the x, that means it is being pushed away from the y-axis because we're changing our x value. So it's going to be a compression because it's 2x. So that means we've got a dilation from the y-axis by a half. The next thing we need to look at is that translation. Now, the translation is we need to be looking at it in terms of the factorized form. So we've got it right here now, x minus 2, which means it is going to be a factor of 2 in the positive direction as for our horizontal translation. Okay, find a sequence of transformations that takes the graph of y is equal to 3 over x minus 1 in brackets squared plus 6 to the graph y equals 1 over x squared. So the first thing we need to do is compare your starting and your target functions. Now, for us to compare, we are really wanting to look at the image. So we need to get it into the same form. Now, to do that, all I'm going to do is get everything that is affecting my y onto the other side. So that means I'm just going to take away 6. So that will give me, I'll write it, y take away 6. And this part here is all timesing by 3. So the opposite of timesing is dividing by 3. So I'll get it divided by 3, and that gives me 1 over x minus 1 squared. So this allows me to view it in terms of what is actually occurring. So now we can look at what is occurring on the left-hand side and what is occurring on the right-hand side. So this is where we are going to make them new values. So we know that if we apply y minus 6 over 3, that is going to give us the image of y. Likewise, if we apply the x minus 1, that is going to give us the image of x. So that is what we need to be getting to, finding the image. So it's just find the sequence of transformations that takes the graph of this into the original graph. Likewise, if I have this the same thing, we're going to again compare. So we're going to look at, we've got y equals 4, x minus 3 in brackets squared, plus 2 to the graph y equals x squared. So again, we are going to get it into all of the dilation of the y and the vertical shift onto the other side. So that means I will take 2 and divide by 4. So that is just trying to get rid of the stretch and thinking about how do we get it back into the original form. Now, from this point is that we are just going to relabel them. So we're going to label them as the image of y and the image of x. Now we're ignoring the squared here because that squared doesn't really matter. It's just this part here is giving me the image of our x value, and the image of my y is everything on my left hand side.